So hello and welcome everyone. Welcome to Kreatryx channel. So first of all, let me introduce myself. My name is Vishal Soni and I have cleared engineering services examination 2 times from electronics and telecommunication branch, both times in double digit rank. In 2014 my rank was 98 and in 2015 my rank was 25th. I have served as a Group A Gastro Officer in Indian Railways and in Indian Telecommunication Services. So most of you must have been following me on the Kreatryx channel for electromagnetic field theory. So if you are a seeker of a free education, this is the channel for you, and you must understand that all these free initiatives is coming your way because of the Unacademy. So Unacademy is the revolution in the field of the free education and the affordable education. So how can you access those free courses? So if you want to access the free courses, you must immediately subscribe this channel, Kreatryx channel, because all the top educators of the country is providing the free course on this channel. And that free course is absolutely brilliant in content, that is systematic, that is organized, and that is complete. So complete playlist you will be getting of a particular subject. You can develop the concept, you can gain confidence. More than that, you can love the subject. So immediately subscribe this channel. Secondly, if you want to access more free content, then you must immediately download the Unacademy Learners app, because on the Unacademy Learners app, top educators of the country are conducting the free special classes. In that free special classes, you can get topic wise clarity of a particular concept. And do not forget to follow me on the Unacademy Learning app. So you can also access the courses. So you must have 2 things. First is your YouTube channel. This YouTube channel, Kreatryx YouTube channel, must be subscribed. Secondly, you must understand that you should have the Unacademy Learning app. That is must for you in order to crack the examination. So these are the parts of the free education. And if you want to organize your content well, if you want more comprehensive manner, if you want other advantages of the Unacademy, then what are the other initiatives that is running by the Unacademy? So another initiative that is running by the Unacademy is Unacademy Plus. So on the Unacademy Plus, this is very affordable for those who actually want to take their preparation to the next level. So आपको Unacademy Plus में क्या क्या मिलेगा? You will be getting the live classes on a fixed time, so that you can get more disciplined, you can get more organized, and you have something in your mind that at this particular time my classes are going to run. Apart from that, you will get free test series designed by the educator itself. So gone those times when we have lot of errors in the test series, we do not have the discussions of the test series. So there the test series will be conducted by the educators. They themselves will be discussing the solutions of that particular thing. So you can imagine that your preparation is going to the next level for this. Apart from that, those who have prepared themselves for the examination, so for them there are crash courses also available. Again the crash courses will going to help you in achieve good ranks. Those who have already achieved good ranks and want to improve their rank, for them there are rank improvement batches. More than that, you can also see that there are unlimited practice sessions. So what do you understand by unlimited practice session? Which means there will be various doubt solving sessions. Apart from the doubt solving sessions, there are weekly quizzes, and with the help of those weekly quizzes you can enhance your problem solving skills. So lot of unlimited doubt solving sessions, lot of quiz sessions, systematic content, structured content. You can download the PDF after the lectures, so you don't have to waste your time in order to making notes. You can utilize those times to practice the particular concepts, or you can use those times to just write down the formulas so that you can remember those formulas quickly. Apart from this plus subscription, there is also one subscription which is known as Iconic. So Iconic subscriptions are for them who actually do not have the self motivation but having the talent. So if they are having the talent and you do not have the self motivation that how can I push myself to crack the examination, so in this Iconic subscription you will be assigned a personal coach. So this personal coach is going to be with you every time, and he will help you to achieve your dreams. You will get a study planner which will be customized for you. You will get the expert guidelines who have already topped the examination. They will be basically hand holding you to crack the examination. So if you think you are not self motivated, if you think you do not have the proper background to crack any particular competitive examination, so this Iconic subscription is must for you. This is going to help you. So if you want the free education, then YouTube channel and the special classes are must for you. And if you can afford a little bit, how much you should afford, that we'll discuss in a while. But if you can afford a little bit, you should come on to this Unacademy Plus. And more than that, if you want the expedited process in your preparation, आप जल्दी से एग्जाम निकालना चाहते हैं, जल्दी से अपनी गलतियां सुधारना चाहते हैं, so this Iconic subscription is for you. Then now let us start today's lecture, which is on the communication system. So now let us start the lecture.
Hello friends, so this is the first lecture of communication system. In the first lecture, we will understand the basics of signals and systems. So for the proper understanding of communication system, we must be thorough with basics of signals and systems. So let us proceed and understand what is a signal. So a signal is a mathematical representation of a physical phenomenon which contains some information. So here are few keywords in signals definition, that signal is nothing but a mathematical representation. And mathematical representation of what? The mathematical representation of a physical phenomenon, and also the physical phenomenon should contain some information. For example, let me consider a physical phenomenon such as AC voltage. We know that AC voltage exists physically. So if I consider a physical phenomenon AC voltage, so I can write AC voltage by a sinusoidal waveform. We know that any AC voltage or current can be represented by a sinusoidal waveform. So this is the physical phenomenon, and this is the mathematical representation of this physical phenomenon. So this is the mathematical representation. Now let me look for some information. So the information present here is in the form of amplitude as well as in the form of frequency. So now let once again correlate the definition, that what is a signal? A signal is a mathematical representation of a physical phenomenon which contains some information, and information here is in the form of amplitude and frequency. So this is the very basic definition of a signal. Some examples of the signals can be this AC voltage. Also some examples can be voice signal, audio signal, and video signal. So these are the few examples of a signal. Now let us understand what is a function. A function is a dependent variable which depends upon one or more independent variables. For example, if I am writing an expression as x of t, so here the dependent variable is x of t itself and independent variable is t. We know that as t changes, the x of d is also changing. So as independent variable is changing, the x of t is changing, or we can say that x of t depends upon this independent variable, or I can write as a function x of t comma lambda. Here dependent variable is x of t comma lambda and independent variable is t comma lambda. So we know that as t and lambda changes, this x of t comma lambda will change, or we can say that this function or this dependent variable is depending on two independent variables t and lambda. So function is a generic term. Now let us understand the difference between a signal and a function. So what is a signal? A signal can always be represented by a function, which means the format of signal will also be some x of t or some x of independent variable. So mathematically signal can be represented by a function, but this function should contain different values at every time instant. So this is the keyword, that mathematically a signal can be represented by a function, but those functions should have different values at each time instant. For example, let me consider this function. Now if I calculate value at different instances, we can see that at this particular instance this function is assuming two values. Similarly, at this time instant this function is assuming two values. For another time instant this function is again assuming two values. So this function cannot be called as a signal. In this function, if I consider different time instances, then at each time instant this function is having different values. So this function always qualifies for the category of signal. this function also has different values at each time instant, then this function can also be called as signal. So a function may or may not be a signal, or we can say that signal is subset of a function. So function is more generic term, and those functions which have different value at different instant of time are known as signal. So from this discussion we must understand that the signal will also look like some dependent variable which depends on one or more independent variables. So let us define few signals. For example, I am writing an expression as x of t. So what is the dependent variable here? Dependent variable is x of t. What is the independent variable? Independent variable is t, and t is generally used for time. So whenever independent variable is time, those signals are known as time domain signals. Similarly, another category, x of lambda. What is the dependent variable here? The dependent variable is again x of lambda. What is the independent variable? The independent variable is lambda, and lambda is known as space. So these types of functions are known as random variables. So whenever independent variable is a space, those functions are known as random variable. Again, x of f or x of omega. So what is the dependent variable here? The dependent variable is x of f or x of omega. More importantly, what is the independent variable here? The independent variable is f, that is linear frequency, or omega, that is angular frequency. So the independent variable is basically some form of frequency. So these type of signals are called as frequency domain signals. Lastly, if I write a function x of t comma lambda, so what is the dependent variable here? The dependent variable is x of t comma lambda. What is the independent variable? The independent variable is time as well as space. So whenever independent variable is time and space, such type of signals are called as random signals or random process. So these are few basic terms which we must be comfortable with, or we must basically understand what is a time domain signal, what is a random variable, what is a frequency domain signal, and what is a random process. Now, what are the types of the signal? So here are various types of signals, but we basically want to study these two categories, continuous and discrete time signal, and time and frequency domain signals. So what is a time domain and frequency domain signal? So we have already understood the representation of time domain as well as frequency domain signals. Let us see some practical examples of time domain and frequency domain signals. So the practical example of time domain signal is an AC voltage. If I have to represent an AC voltage, I will always use the time domain representation, that is x of t equal to a cos omega naught t. So this is the time domain representation of AC voltage. There are some standard signals in frequency domain also, such as voice signal, which is having frequency from 300 Hz to 3.5 kHz, an audio signal which has frequency from 20 Hz to 20 kHz, a video signal which has frequency from 0 to 4.5 MHz. So basically these frequencies are important, so you must understand or you must remember these frequencies. Also the practical examples of time domain and frequency domain signal. In the next slides we will discuss more about continuous and discrete time signals. So here we just want to discuss what is a continuous time signal and what is a discrete time signals. In continuous time signals, independent variables are the continuous time t and the representation will be some form of x of t. In discrete time signals, the independent variable is a discrete time and general representation will be x of n. And here we must remember that n always assumes integer values or n always belong to integer. Now discrete time signals are generally obtained from continuous time signals by a process called as uniform sampling. So in coming lectures we will study more about sampling and all, but here I am giving some basic idea of sampling. Suppose I have a continuous time signal as e power minus t. So the graph of e power minus t versus t will be something like this. This is the graph of e power minus t. Now if I sample this signal, for sampling I will use a switch which closes at every ts interval and I want to write the output. So the switch closes at every ts. Now at t equal to 0 the output will be 0. At t equal to ts the output of the switch will be x of ts. At output 2 ts the output of the switch will be x of 2 ts, which means this switch is momentarily closing at these time instances and it is opening again. Now it is again closing for a moment at t equal to 3 ts and output will be x of 3 ts. So this is our signal x of t. Now let me draw x of nts versus nts. So we know that the sampling instances are 0 ts, 2 ts, some minus ts. So these are the sampling instances. So this value will be x of 0, this value will be x of ts, this value will be x of 2 ts. So this switch is closing at t equal to 0 for a moment, so it will take this sample out at its output. Now the switch is closing exactly at t equal to ts for a moment, so it will take this sample at its output. Similarly the sample present at 2 ts will be coming at the output. So from here we can see that x of nts is present at discrete instances of time, or we can say that a continuous time signal has been converted into a discrete time signal. So basically the uniform sampling represents the discretization of time axis. So this line is very important, or this statement is also very important, that uniform sampling performs the discretization of time axis. So these are the few basic terms about continuous and discrete time signals. Now let us have a look on some basic signals. So we will understand basic signals of both continuous time signal and discrete time signals side by side, and we will be dealing only with those signals which we will be using further in communication systems. So first signal is unit impulse signal. So a continuous time unit impulse signal is represented by del of t, or it can also be written as 1 into del of t, and this 1 represents the area of impulse signal. Since area is unity, hence the name is unit impulse. The graph of this continuous time unit impulse signal can be drawn like this. This is the graph of continuous time unit impulse signal. Now what is the definition of this signal? So the definition can be broken into three parts. First, that del of t is 0 whenever t is not equal to 0. So at all those instances where t is not equal to 0, this function does not exist, or we can say that del t will always be 0 whenever t is not equal to 0. Second, del t is not equal to 0 at t equal to 0. So exactly at t equal to 0 this graph exists, and exactly at t equal to 0 its value will be non-zero. So what can be the value? We know that at t equal to 0 impulse signal tends to infinite. So here we have already studied in signal that for unit impulse signal the value at t equal to 0 tends to infinite, and this one basically represents the area of impulse. So this area definition I am including that whenever we want to calculate the area of unit impulse signal, it always gives us a unity area. So these few definitions are very important, or this area can be further broken as 0 minus to 0 plus gt, because this impulse is existing between 0 minus to 0 plus. So this is the definition. So we must understand that del of t does not have a value of 1 at t equal to 0, rather it is having an area of unity. Now second is discrete time unit impulse signal. So the discrete time unit impulse signal is represented by del of n, or I can write it as 1 into del of n. Now in discrete time impulse, this one represents the value of impulse signal at n equal to 0. So this is the very basic difference, that del t has area of unity and del of n has value of 1 at n equal to 0. So if I make the graph of del of n, the graph will look like something. So this is the graph of del of n versus 1, and this value will be 1. So the definition is very simple, that del of n is 0 when n is not equal to 0, and del of n is 1 at n equal to 0. Also this value will be 0, and we can write that if I want to calculate the summation from minus infinite to infinite del k, so this value will be 1. So So these are the few basic properties of unit impulse signal. Now few properties of impulse signals. So first of all, properties of continuous time impulse signal. So I'm just writing the properties. That first property is, we know that del of AT is nothing but 1 by mod del of t, and del of minus AT plus B will be, you can write it as del of minus A t minus B by A, or 1 by mod A del of t minus B by A. Third property is, we know that sampling property, that if any function is multiplied with unit impulse signal, so it will sample this signal, and we know that this function is present at t equal to 0, so we can directly put t equal to 0 here and function becomes f of 0 del of t, or f of t equal to del of t minus t naught. We know that this function is present at t equal to t naught, so we will put t equal to t naught here, so it becomes f of t naught del of t minus t naught. Another one is ft del t dt. So inside the integration we can write it as f of 0 del of t dt. F of 0 is constant, so it comes out of the bracket, and integration of del t dt we know that is f of 0. Similarly, we can write minus infinite to infinite f of t del of t minus t naught. So we can put t equal to t naught here, and it becomes minus infinite to infinite f of t naught del of t minus t naught dt, or I can write it as f of t naught minus infinite to infinite del of t minus t naught, and area of impulse is always equal to unity. So the value can be written as f of t naught. So here we are basically concerned with the properties of continuous time impulse signal. Once we will reach to the chapter of PCM, so I'll again explain the properties of discrete time impulse signals. Now next important signal is unit step signal. So the unit step signal is represented by 1 of ut, and this represents step change of 1 at t equal to 0. The graph of unit step signal is something like this. It will be 0 for t less than 0, and it will make a step change of 1 at t equal to 0. So the definition of ut becomes 1 for t greater than 0, 0 for t less than 0, and exactly t equal to 0, its value becomes indeterminate. What is the difference between indeterminate and undefined? Indeterminate means we know that the value will be finite. It is the value between 0 to 1, but we are not sure which value we should take, 0 or 1. And what is the undefined? Undefined means the value of del t at t equal to 0. Since the value of del t at t equal to 0 tends to infinite, hence this comes under the category of undefined. So undefined means tending to plus minus infinite, and indeterminate means the value is finite but we do not know what exactly is the value. And this indeterminate value can be calculated by using Gibbs phenomenon. Gibbs said at any point of discontinuity, if you want to calculate the value, you have to take the average of preceding value and succeeding value. So preceding value is 0, succeeding value is 1, and average is always going to be 1.2 or 0.5. So exactly at t equal to 0, unit step has the value of 0.5. Next important signal is unit ramp signal. So unit ramp signal is represented by R of t equal to TUT. The graph of unit ramp signal can be drawn something like this. The definition of unit ramp signal that it gives the slope change of unity at t equal to 0. So here the slope will be 0, and exactly at t equal to 0 it will give the slope change of unity. Another important signal is unit parabolic signal. We know that unit parabolic signal can be represented as t square by 2 ut. And the graph of unit parabolic signal will be in the form of parabola. For less than 0 it will be 0, and for greater than 0 the parabola rises. So these are the few basic terms. This we have already studied in signals, but we must be having few basic idea about it. Next important signal is a rectangular pulse signal. So a rectangular pulse signal is represented by rect of t by t. Rect of t by t represents a signal which is symmetrical about vertical axis and it is having the width of t and peak value as 1. So this signal is having width of t and it is having the peak value as 1. Also, this signal is an even signal because it is symmetrical about vertical axis. So sometimes this signal is also known as gate function. And if I have to write a rect of t by t, so the graph of a rect of t by t will be, again this represents the width. So width will be t and it is symmetrical about vertical axis, so it will distribute from minus t by 2 to plus t by 2, and peak value again will become a. Next signal is a triangular pulse signal. So a triangular pulse signal is represented by tri of t comma t, and it represents half of the width. The graph of this signal will be a triangular pulse from minus t to plus t, and peak value of this signal will be 1. So mathematically this tri t of t can also be written as 1 minus mod t by capital T, where mod t lies between less than or equal to t. Now if we break this function, we can write it as 1 plus t by t and 1 minus t by t. This 1 plus t by t will be when minus t to 0 and t lies between 0 to t. So these are basic functions which we must understand, and in the next lecture we will study some more basic functions.
So if you have liked today's lecture and you want to subscribe the Unacademy Plus, the very first thing that you should understand that you should use this particular code. What is the code? The code is Vishal Gate. Write my name and attach Gate to it. So by using this particular code, you will be getting all the advantages of the Unacademy Plus. All the added advantages will be directly assigned to you. Secondly, you will directly come to under my guidance, and that will surely help you to crack the examination in the least possible time, and you will also get the guidance of the complete team. Okay, and the most important thing is that you will immediately get the 10% discount on that. So immediately you are enabled to get 10% discount once you use this coupon code. So for example, if you talk about the plus subscription, which is costing you 25,000 for 1 year, and if you use this coupon code VishalGate, immediately you are going to get 10% discount, which is 22,500. And if you talk about the iconic, for the iconic subscription of the 12 month, this will cost you around 40,400. So these are the cost of the 12 months. And if you want to talk about the 2-year subscription, cost of the plus, it is your 27,000 after discount. If you want more discount than 10%, and you have already attended the special classes, then you will be having some credits in your account. Do not forget to use those credits so that you can get more discount than 10%. Now, how can you pay these amounts? So there is one good news for you, that you can pay this amount by using credit cards and debit cards by using the facility of the zero cost EMI. So if you want to pay this particular amount of 22,500 with the help of zero cost EMI, so the zero cost EMI can be availed by using credit cards and debit cards. Remember, you can use the credit card of any company, but the debit card is allowed for HDFC and the Bajaj Finserv. Apart from that, if you want to directly pay this much of amount, you think that this particular amount is the most affordable fees that can be provided to you for 1 year subscription, तो आप directly क्या कर सकते हैं? You can use this credit card, debit card, direct payment. You can also go for the EMI options, okay, and you can directly pay this amount by using net banking. Every time you think of the Unacademy Plus subscription, the first thing that should come in your mind is this particular code. Do not forget to use this code once you take the subscription, because I have already told you that this particular coupon code is going to give you the lot of advantages, so you cannot miss the opportunity to use this code. So every student who want to come on to the Unacademy Plus, they want to take the advantages of the Unacademy Plus, they want to empower themselves in the best possible manner in this digital era, they want to be the part of this revolution, then this is the time for you. You do not have to wait for it. If you are in the first year, if you are in the second year, you are in the third year, the best possible time is right now to prepare for the examination, to dedicate yourself, to give yourself the opportunity so that you can get the success as early as possible. Apart from that, you should also join this GATE aspirant group. So this GATE aspirants group is already having 150k plus students, so you can join it. There are a lot of discussions going on between students. You can get the advantage of those discussions. Okay, you can also join this Kreatryx channel, which is a Telegram channel. So everyone has to join this channel so that you can get all the PDFs of the lecture which is being assigned to you. Fine. There are various channels which you can go for it. So various channels in the association with Kreatryx. So you can follow the channel of your interest. And this is it in today's lecture. So let us meet in the next lecture. Thank you so much.